Have you ever worked on a team project where things just don't match? Your app works on your machine, but not on someone else. The database is different, the data is missing, someone says, send me the latest database. And suddenly, everyone's confused and frustrated. This video starts right from there. Imagine you are working on a team project. 2, 3 or even more developers are working together. Everyone is on different machines in different places, but it's still the same project. And in this situation, the biggest and most common headache is the database. MongoDB is running on your machine. Someone else might not even have it set up yet, and another person could be working off a database dump from last week. You build a new feature today, new data gets added to the database, but the rest of the team doesn't have that data. Then you say, hey, send me the latest database dump. And then it starts zipping the file, sending it, restoring it, and still ending up with mismatches. In team workflows, this gets insanely annoying. To avoid this hassle, we usually spin up a cloud database. MongoDB Atlas, Supabase, Railway, RDS, whatever it is. But the moment you go to the cloud, a new set of problems start. It costs money. Security becomes a concern. There's fear of credential leaks. And most importantly, that natural local development feeling disappears. A lot of the time, setting up all this just to work within a team feels like overkill. So, at this point, a very simple question comes to mind. If the database stays local and the whole team can use it, why do you need to take dumps at all? And why do you need to push it to a public cloud? The database will run on your machine, but teammates will be able to access it like you are all sitting in the same room. And to bring back that same room feeling, we need a private network that runs over the internet, but behaves like a local network, right? And that's exactly what Tailscale is for. Tailscale basically brings your team's machines into a small private network. From the outside, everyone is in different places. But from the network's point of view, you are in the same place. You can think of it as creating your own Wi-Fi for the team. The difference is, this Wi-Fi isn't created by a physical router. It's created over the internet and fully controlled by software. I won't drag this into more theory. Let's jump in because you understand it best while doing it. First, I open my browser and go to tailscale.com. Before anything, we need to create a Tailscale account. Up top, you can see a button that says Get Started. It's free. I click that. After clicking, you will see a few options: Google, GitHub, Microsoft, and so on. Pick whatever is convenient for you and create an account. After the account is created, a welcome page will appear. On this page, Tailscale asks for some basic information. Just fill in the relevant details. Once everything is filled in correctly, we move to the next step. Now, look near the bottom. There's an option that says, Next, add your first device. I click that. In this step, Tailscale tells us, let's add your first device. From here, you can directly download Tailscale's desktop app. But I'm not doing that from here right now. I scroll all the way down and there's an option called Skip this instruction. I click it to skip this step because a bit later we will install Tailscale ourselves based on our OS. After skipping this step, what I see now is the Tailscale dashboard. This dashboard is basically the control room of our entire private network. From here, we will manage which devices are in this network. We can talk to whom and which ports or services will be open for whom. Everything. Now, we will install Tailscale on our own machine. Let me make one thing clear. We are not going to use the desktop software here. We will do everything via the CLI because for team projects and development setups, using the CLI or command line interface is the most practical and predictable. Since I am using a Mac, the easiest way here is using Homebrew. I open Terminal and I'm assuming Homebrew is already installed on your machine. Now I type brew install Tailscale. After running this command, Homebrew will automatically download and install the Tailscale CLI. For Windows user, first go to Tailscale's official download page. From there, download the Tailscale installer for Windows and install it. Once installed, the Tailscale CLI is automatically set up on the system. If you have trouble installing, there will be a documentation link in the video description. Check that. For Linux user, the whole thing is done via the terminal. Open terminal and type curl fsl https tailscale.com/install.sh pipe.sh. Here, we are using Tailscale's official install script. So, there's no distro-specific hassle. This script automatically installs the required things based on your system. I will include detailed instruction documentation in the video description. Whatever OS or distro you use, just check from there. After the install finishes, I want to make sure everything installed correctly. So I type Tailscale version. You can see it shows a version. So the Tailscale CLI is installed correctly. Now that Tailscale is installed, we will bring this machine into our private Tailscale network. For that, I type sudo tailscale up. For Windows user, in PowerShell with administrator permissions, run tailscale up. As soon as I run this command, I see a login URL in the terminal. I copy that URL and open it in the browser. It asks me to log in with my Tailscale account. And I log in. As soon as I log in, it says connect device. If you want, you can click the device details button to view the device details. Now, I click the connect button. Our login is now complete and our device is connected. I go back to the terminal and you can see it shows success there too. Now, we will check the status. In the terminal, I type Tailscale status. You can see it's connected. The device named Rafi's MacBook Pro is connected. And you can also see it has given an IP. In my case, it's 176.93.28. In your case, it will be different. So this machine is now part of our private network. This machine now has a private IP that doesn't work on the public internet, but every other machine inside this Tailscale network will be able to see this machine. Once we reach this point, our own machine is fully ready. This machine is no longer just a separate computer. It's now part of our team's private network. Now, I go to the dashboard again to check whether our machine has been added as a new device. And yes, it's there. This is the most important thing. Your machine isn't just on the internet anymore. Your machine is now inside the private network you created. That's why it gets a private IP. It won't work on the public internet, but anyone in your team who's inside this network can access your machine using that IP. So what you are doing here is not making a public server. It's making a machine available inside a private network. Now we need to install MongoDB. For that, go to MongoDB's official website. On the download page, you will find the installer based on the operating system you are using. Download it and install it. The installation process is usually straightforward, so there's no need to show it step by step. Once MongoDB is installed, we will open MongoSH. To start MongoSH, type this in the terminal, MongoSH. You can see our local database is connected. Let me be very clear here. I am not opening MongoDB to the public internet. I am not using a public IP, and I'm not doing any router port forwarding. But yes, I am explicitly exposing MongoDB inside the Tailscale network, meaning only the devices that are part of my Tailscale network will be able to reach this MongoDB. Right now, MongoDB is running with its default behavior. MongoDB is only bound to localhost. In that state, even if you have Tailscale, you still can't directly connect to MongoDB from another machine. So here, we need to tell MongoDB, in addition to localhost, listen on this specific network IP. So first, I will find my Tailscale IP. I open the terminal and type Tailscale IP. Here I can see an IP like 176.93.28. This IP is very important. It's not a public internet IP. It only works inside our Tailscale private network. This is the IP we will bind MongoDB to. Now, I will open MongoDB's configuration file. The file name is mongod.conf. The location of this file can be a bit different depending on your operating system, but the concept is the same for everyone. Since I am using a Mac here, I open terminal. If MongoDB is installed via Homebrew, the config file is usually at opt homebrew etc mongod.conf in case of Apple Silicon Mac, or user/local/etc/mongod.conf in Intel Mac. If you are not sure which path you have, you can run psaux pipe grep mongod to find the currently running MongoDB process. And often you can see which configuration file MongoDB is using. You can see it shows the paths clearly. Here I can see it's using opt homebrew etc mongod.conf. And if you are on Windows, you can use tasklist pipe find str mongod in command prompt or get process mongod in PowerShell to check whether a MongoDB process is running. On Windows, MongoDB usually uses a config file path like C program files MongoDB server any MongoDB version /bin/mongod.cfg or C program files MongoDB/server any version /bin/mongod.conf. Now, in the terminal, I type nano opt homebrew etc mongod.conf. Now, the file is open in nano. If you want, you can use another editor like VS Code. Once the file is open, I go to the network section. Here I can see a section called net. Inside it, there's a property called bind IP. If you look closely, by default, you will usually see something like bind IP :127.0.0.1:1. This means MongoDB only accepts connections from localhost. In other words, nobody except this machine can connect to MongoDB. Now I make a small change right here. I keep localhost because I want local development to keep working exactly as before. And along with that, I add my Tailscale IP. I found that IP a little earlier using Tailscale IP and copied it. This Tailscale IP is not for the public internet. It only works inside our Tailscale private network. Now on the bind IP line, after :y, I add a comma and then add this Tailscale IP. This means MongoDB will accept connections from two places. One, localhost on this machine. Two, connections coming from inside the Tailscale network. After making this change, I save the file. In Nano, I press Ctrl+X and then Y, then Enter. Now, there's a very important step. You must restart MongoDB because we changed the configuration file and MongoDB won't pick up this change automatically. If you don't restart, the new bind IP setting won't work. Since I am using a Mac and MongoDB was installed via Homebrew, I restart MongoDB with this command: brew services restart MongoDB -community @7.0. For my case, it's 7.0. Yours one can be different. As soon as I run this, Homebrew stops the MongoDB service and starts it again. It restarts within a few seconds. On Windows, to restart MongoDB, open the Services app, find the MongoDB service, then right-click and select Restart. Or open PowerShell as administrator and run Restart Service MongoD or Restart Service MongoDB. If you are using Linux, MongoDB usually runs as a system service. In that case, use this command to restart it: sudo systemctl restart MongoD. After the restart, I verify everything is okay. I type mongosh again. It connects locally. So localhost is working just like before. There's no error, which means the configuration change was applied safely. Now, this is where the main thing happened. MongoDB is now listening on my Tailscale IP. That means if anyone on my team is inside this Tailscale network, they can now connect to MongoDB directly using the name Rafi's MacBook Pro or using this Tailscale IP. Notice this carefully. We didn't make MongoDB public. Nobody on the internet can get into it. But we also didn't keep it locked as only on my machine. We turned it into a private network resource. At this point, we will invite our teammate to Tailscale. For that, we go to the Tailscale dashboard. Click the Users tab, click the Add External Users button, select Invite via email, enter my teammate's email, and keep the role as member. Now, an email will be sent to our teammate. So, I switch to my teammate's screen, open the email, and click the Join the Rafi Udaraj network button. If my teammate doesn't already have a Tailscale account, they can create one the same way as before. Once the account is ready, they click the Join Tailnet button. Now it says you need to be approved. So from our Tailscale admin account, we approve the permission. Now my teammate is approved. Next, to connect their device to our private network, they need to install Tailscale on their device as well. Earlier, we installed Tailscale using the CLI. This time, just to show it, we will install the GUI-based desktop application. Same way, go to Tailscale's website, go to the download page, download Tailscale for whichever machine you are on and install it. Now, from the top taskbar, we open Tailscale, click Settings, then click Accounts, then click Add Account. A browser will open. Now, we log into Tailscale. Then, to connect the device, we select Rafi Udaraj and click the Connect button. That's it. Now, our teammate's device is also connected to our network. Now we turn Tailscale on. And now from our teammate's terminal, we access the MongoDB database. For that, in the terminal, we type mongosh mongodb :/1769328:27017. Nice. We can access the database from our teammate's device. You can see it clearly on the screen. We are sitting in different places, but still using the same database. This is that like a local network feeling we wanted from the beginning. Now, I want to show you one more thing. Without this, you won't fully understand Tailscale's real power, and that is access control. Creating a private network is one thing, but being able to control who can access what is another. To keep it simple, I won't use the database as the example. I will use a new example so it's easier to understand. So let's run a Next.js project on our local machine. I go to my project folder, then in the terminal, I run npm run dev, just a simple Next.js starting command. After a moment, the Next.js app is running properly on localhost 3000 port. I open it in the local browser and everything looks fine. Now, here's an interesting point. Since my machine is inside the Tailscale network and my teammate is also part of the same private network, the question is, can they see this app that's running locally on my machine? Let's check. Now I go to my teammate's machine and open the browser. Then I type my admin machine's Tailscale IP and add 3000. Like this. Admin IP, then colon, then 3000. And as soon as I hit enter, look what happens. My teammate can actually see the Next.js project running on my local machine. No deployment, no cloud hosting. Still, they can directly access my local app. In a way, that's expected because we learned exactly this. But notice something. We gave them access to the database, but we never gave them permission to access port 3000 on my local machine. Getting automated access like this isn't okay. Technically it works, but from a security point of view, it's not good. Because now if someone only knows the IP and port, anyone inside our private network can jump into my local services. Today, it's a Next.js app. Tomorrow, it could be an admin panel, a database, a debug server, or any other sensitive service. This is exactly where ACL comes in, access control. Now, we go to the admin dashboard. From the top tabs, we click access controls. As soon as you come here, you can tell this section is for network level permission control. From here, we can decide who can talk to whom, which machine they can reach, and which port they can use. You will see there's a default rule already added. And by default, it allows all traffic. That means everyone inside the network can communicate with each other on any port. Now, we delete this default rule and we want our teammate to no longer be able to access port 3000 on my local machine. In other words, we want the Next.js app running on my local machine to be blocked for the teammate. Now, we click the Add Rule button. After clicking, we can see a few important fields: source, destination, port, protocol, and node. First, source. Source means who is requesting access, which user, which device, or which group the request is coming from. For example, it could be all users, a specific user, or a device with a tag. In simple terms, source is where the request is coming from. In our case, our teammate is say hi to Rainmaker. So we set the source to say hi to Rainmaker. Next is destination. Destination means which machine or resource is being accessed. Here, we usually use a device name like Rafi's MacBook Pro, an email, or a specific tag. In other words, source is trying to go where. That's destination. In our case, we want the request to target our admin machine. Our admin machine is Rafi Udaraj. So in destination, we put Rafi Udaraj. Next, the most important part, protocol and port. Here, we specify exactly which port and which protocol will be allowed or denied. In our case, the Next.js app runs on port 3000 and we don't want to give our teammate access to Next.js. We only want to allow MongoDB database access. So here, we explicitly put port 27017. And finally, note. This is purely for documentation. Here, you can write why this rule was created. In the future, if you or someone on your team looks at it, they will understand what the purpose of the rule was. I'm not writing anything here for now. As soon as we save this rule, the policy will be applied across the entire network. Now, we go back to the teammate's machine. We refresh the browser. The Next.js app that was loading a moment ago is not loading anymore. The connection has been blocked. That's the real power of ACL, right? And you will notice we can still access the database perfectly fine from the teammate's machine. Now, one more thing needs to be clear. This is not only for MongoDB. For PostgreSQL, the port is 5432. For MySQL, it's 3306. For Redis, it's 6379. The service can be different, but the concept is exactly the same. Because we didn't teach a specific database here. We learned one thing: how to build a secure virtual private network over the internet and share your team's local services without making them public. And the best part is, you can apply this not only to a database, but to any local service. API server, admin panel, internal dashboard, staging service, whatever it is. You can share everything privately inside your team. And you can also use ACL to control who gets access to what. So that was the full workflow. One thing to keep in mind though, this setup depends on the host machine being online. Since the database and services are running on a local machine and not on a cloud server, that machine must stay connected to the internet. If it goes offline, other team members won't be able to access the database or any services running on it. This is a live peer-to-peer setup, so availability is tied directly to the host machine. As long as you understand that trade-off, Tailscale becomes a powerful, simple way to build a secure private network without the complexity of traditional infrastructure.